This is AP Calculus Unit 8 Pretest Solution. Let's go ahead and write. We're working on the answer key here. This video is being recorded February 11th, 2022. Happy birthday, Mom. All right. First problem, we are going to be needing a calculator, so let's go ahead and drag this. Is it not going to let me drag it if I use the stylus? Nope. All right. Let's go ahead and type these into our y equals. We've got a 95 times the square root of this x, and then hit right to get out of the square root. Then we have sine. So there, notice that it says sine squared. That's just a notation thing. Really, this is sine t over 6 then squared. So I'm going to say sine of x divided by 6. Then I'm going to square that. That's the way that you type it in the calculator. It's a little bit funky, I know. And then our y2, we're going to say 275 times sine of this t over 3. So it's going to be x divided by 3, and then I'm going to square it. And right away, I know that one of them is going to be positive, which one is going to be negative. So pumped into is a word meaning positive, so this is going to be our positive rate. And removed, which is going to be our negative word, which means this is going to be our negative rate. And you always are going to do positive minus negative. I have two functions, so I'm going to do vars right, enter, enter, y1, minus my vars right, enter 2, my y2. And I'm going to go ahead and not graph those. I'm going to hit enter on the equal to sign, hit up here, hit enter, that way they're not graphed. And do I have any interval over here? Yeah, so 0 to 18. I should maybe zoom out a little bit so I can see everything. There we go. So if I come over here to my window, I'm going to say 0, enter, 18, enter. And then I'm just going to hit zoom 0, let this graph. I don't know if I'll need that graph, but maybe. So over here, let's finally ask the question, is the amount of water in the tank increasing at time is equal to 15? Why or why not? So first of all, notice our units here. It's an amount of water. Are we asking for the rate of the water? Are we looking for the amount of water? We're not looking for the rate. This is the amount. It says amount. This is the, I'm using air quotes here. This is the position of what's happening. So, and we're going to do what? This word increase or the word decrease. Either one means take the derivative. So I'm going to type in here. This means derivative. So I don't know why it auto-capitalized. It's kind of annoying. Take the derivative of the thing I was talking about. Take the derivative of the amount of water. And if it is positive, it is increasing. And if it is negative, it is decreasing. So at time is equal to 15. So essentially, we need to do the positive minus negative. But why? Why aren't we just using one of the equations, Mr. Sindel? Well, it's the total amount of water. This is kind of like it's not saying this, but I'm interpreting this as the total amount of water in and out. So it is asking for both of these. It will be very specific. If it's only asking about entering or leaving, it'll have that word. If it doesn't have that word, assume it is both of these. So it's asking, hey, W of 15, that is the derivative of the water at 15, entering, and then capital R of 15, is this value, which is this graph here at time is equal to 15, is that height on this graph positive or is it negative? So I can come here to trace and I type in 15, I hit enter, and notice that our height down here is negative, which means, again, this is kind of like the graph of air quotes velocity, and notice that our derivative here is negative, therefore we are decreasing. So this value is, well, I mean, I can tell you that it is exactly equal to negative 121.090. There's a 0 after this. And that number happens to be 0 or less than 0. That means it's negative. So in conclusion, no, it is not increasing. This value, the amount, thank you for autocorrect, of water is decreasing at time t is equal to 15. Because, and it's the same thing that we just typed up here, wrote up here, W of 15 minus R of 15 is less than 0. And again, another way of saying that is that W of 15 is less than R of 15, because you could add R of 15 to both sides. Either way, we're good. What about part B? I'll zoom out a little bit. To the nearest whole number, how many gallons of water are in the tank at time is equal to 18? We're looking for an end amount. How many gallons? That is an end amount, right? So we're going to do our start. I guess our T for time we can do. At time is equal to 18. What is our start plus change? that will be equal to the end, the thing that we care about. I totally forgot. Was there a start? Okay, yeah, there is a start. The start amount is 1,200, and the start time is 0. So remind yourself that when you're doing an integral, the time will start at 0. That's what this 0 right here means. Start is 1,200, 1,200. Write that down here, plus, and then the change is going to be the integration of, I mean, air quotes, velocity of this thing, but instead of 15, it's just t, right? W of t minus r of t dt. So we'll do in parentheses here, capital W of t minus capital R of t in parentheses dt. Do you need to be formal about this? Kind of, yeah, you should do it. The only time I'm not formal is when I'm in a table, when I'm in a rush. Calculator, come on, wake up. Let's do some manual labor here. Yeah, clear out of this. Go away. Thank you. What do we have? We have 1,200 plus math 9. And it's going to be in... Ooh, yeah, what are our bounds? I totally forgot. I told you that it started at 0, and our bounds are going to go all the way to time is equal to 18 right here. So there's our bounds. So coming back over here, 0, hit up. Come on, up. And then 18, our bounds is going to be, and W of t minus R of t, that is our y3 function. So I can just hit vars right, enter 3. And we have our y3 function with respect to x and nothing else. We can hit enter, and we get our final answer as, calculator, come on. I believe in you. I'm going to get ready right. There it is, 1,309.788. But wait, there's more. To the nearest whole number. If I come back and read the problem, whole number means an integer amount. So round, in this case, up, because this number is 5 or greater. So this is going to turn into 1,310. What are our units here? Gallons. Gallons of water. So I'm going to say GAL and call it good. And I don't know what happened to my computer. Gotta love the lag. All right. Wow, I can't even draw the box. Come on, computer, keep up with me. I know I'm not that fast. All right. And part C, at what time in t, between that interval 0 to 18, is the amount of water in the tank the absolute minimum? Again, we're looking for a min. Show work that leads to your conclusion. All right, well, a minimum or maximum, when we have a calculator, means a table. If we don't have a calculator, there's another way, but you can still use a table. It's just harder. All right, so our table is going to have a t. We're going to have a start. We're going to add a change. And that will give us our end values, and we will select the smallest of those end values. So let me set up my table. I have technology, so you know I'm going to make some straight lines here. Bada bing, bada boom, and look at that. We've got a pretty snazzy... it was a snazzy table. Now it's a snazzy table. All right. We always want start and end, 0 and 18. Those are always possibilities. Do you want critical values or relative extremums? I mean, I'm going to do all of the relative minimums for my table. How do you know what's a relative minimum? Well, we have this fancy graph. A relative minimum, as a review of what a definition is when you take the derivative, hey, this is a graph of that derivative, and you go from a negative to a positive. And I'll write that down over here. An f relative minimum is when you take the derivative of the thing you want, you get an f prime, and that goes from a negative into a positive. Well, what do we want here? We want the amount of water to be a minimum. So this is kind of like my f. If I'm looking for f prime, then I need to find the rate of the amount of water. And hey, we have an equation for the rate of the amount of water. So we're going to take that rate, which is the derivative, that is our f prime, and we're going to look where that rate goes from a negative to a positive. And this is the equation of that rate. Where does this have a height that goes from a negative to a positive? Why height? Because this is a graph of the rate. And what is height? It's also a rate. All right, so it goes from a negative height to a positive height only at this one spot. This is a relative minimum. This is a relative maximum over here because it goes from a positive height to a negative height. All right, so we need that t value. Come back here. We're going to do a second trace to do a calculation, and we want to find that 2, the 0, and it's about right there. So I'm going to say my left bound is, I don't know, 1. My right bound is 10, and anywhere in between 1 and 10 is fine, like, I don't know, 7. And I get 6.495. So 6.495, and sometimes you want to include the other critical value, but it's never going to be the answer. So I'm going to ignore it. Maybe I should have brought that 6.495 down a little bit. That's right in the middle. Looks good to me. All right, our start amount is going to be repeatedly 1,200, 1,200, and 1,200. Our change here is going to be the integral from 0 to what, plus the integral from 0 to what, plus the integral from 0 to what? Well, 0 to this time, 0 to 0, 0 to 0, 0 to 6.495, 0 to 18. And of what? It's basically capital W. Come on, computer, keep up with me. Capital W minus R, capital W minus capital R, capital W minus capital R. Again, see, I'm being informal about my table, but I think that's fine. This is just giving the general explanation of what I'm doing. Well, 0 to 0 is not going to be anything. So the end amount is the start amount because we haven't moved. It's still at time is equal to 0. That makes a lot of sense. Let's use our calculator here. Get out of this. Type in this. We have 1,000. Oh, wait. I'm doing that function. I could just do a second enter to do the previous entry, and then instead of bounds of 18, I can do a bound of, I could just retype over this. I don't have to hit delete. I can just hit 6.495 and hit enter, and it will do its thing. Again, our decimals will be a little bit off depending on the model of calculator that I use, but you should get 525-ish gallons. So I'm going to come back over here. 525. I'm going to show my decimals to show you what I got, but again, the decimals don't matter in this case. 2, 4, 2. And then, didn't we do 0 to 18 up here already? We know that end amount. It's 1,310 when I rounded, but 1,309.788. I'm not going to do that again. All right, ladies and gentlemen, which one of these three numbers is the smallest? Ah, yes, this one. Very good. So let's go ahead and, as always, write our final solution out in words so that we say the time and the amount. I know it's only asking for the time. It says this right here. At what time? And it doesn't ask for the amount, but I'm going to do both because sometimes questions will ask for amount, sometimes they'll ask for time, sometimes they'll ask for both, but if you explain both, you can't lose points. So please use that strategy as well. So there is an absolute minimum at t is equal to 6.495 with 525-ish, I'm just going to say 525 gallons. Cool. And that's part C. And now on to part D. For t is equal to 18, or t is greater than 18. Okay, so we're after the problem is done. Remember that our problem ended at 18. It's now saying, hey, when you go beyond the problem, when it is bigger than 18, no water is pumped into the tank, but water continues to be removed at that rate that we had from up above until the tank becomes empty. Okay, so K for constant, I'm guessing. K be the time. Oh, no, it's a time. It's not a constant amount. K be the time at which the tank becomes empty. Right, but do not solve. Oh, God, I love these problems. Do not solve. Thank God. An equation involving an integral expression. Okay, I can do this. So, well, what is the starting amount? Remember, at time is equal to 18, where were we? We were at 1,309.788. So I'm going to start at that value and eventually get rid of gallons. So I'm going to start, again, essentially what we're doing is we're doing start plus change is equal to end, But our start, we're starting now at time is equal to 18, right? And at time is equal to 18, we have a value in our table for that amount. It's 1,309.788. Okay. Plus, we're going to do an integral. It does tell us we're going to have an integral. Plus the integral from where to where. And this is where you have to be careful. It's not from 0 anymore. It's from 18. That's our new starting time because it says so right here. And we are going to end at some time that we don't know. And that time that we don't know, it says, hey, call that time K, and then it will be empty. So there it is. At that time, it will be empty of, okay, and then what is our rate? Well, it's being removed at this capital R. So I'll say capital R of T. It is important to be formal because we're given an answer, not an explanation. R of T dt. And when this hits that value, then it will be 0. Then the end amount will be 0. And I have now made an equation that solves that value for K. Congrats. All right. Well, how do we score this thing? It's going to add up to 9. Let's switch to our red ink. I'm going to give you just 1 point for this first part. So let's zoom out even more. Where do I have room? I have room on the right. So this is going to be out of 1, then out of 3, then out of 3. What is that? 6, 7, 8, 9. So this is going to be out of 2. All right, I will give you 1 point if you give me an answer and an explanation. So you have to say both decreasing and you have to say because of this thing. Together, those are worth 1 point. If you missed either one, you get 0 points. There is no partial credit on an AP test. For part B, I'm going to give you, if you just wrote the bounds 0 to 18, that's going to be plus, I'm getting weird lag in my computer. Oh, wow, this calculator was giving up on life. Plus 1 point if you got the bounds. I will give you plus 1 point if you wrote this capital W of t minus R of t, and you have to have the dt. Everything here needs to be formal. Everything needs to be perfect. And if you do that, another plus 1. And finally, if you got the end amount, the rounded end amount, mind you, not that one, but this one. If you get that one, that's another plus 1 point. In part C, how to score yourself, this is going to be out of 3. I'm going to give you 1 point if you ever considered 6.495. I'll give you 1 point if you have a table, a reason. So I'm just going to say all of that, that's a terrible curly brace. That's a much better curly brace. If you wrote a table, give yourself a point. And if you made the correct conclusion that the minimum does indeed happen at that 6.495, then I will give you another final point. All right. For part D, 2 points. This is out of 0 though, because I remember that I made this extra credit. There are 2 points here, but I'll give you extra credit because this was an atypical, a harder question, although it is an AP question. I will give you 1 point if you got the bounds from 18 to K, so that's going to be plus 1 point. And I'll give you 1 point if you wrote everything else. The R of t dt equal to 0, the starting amount, all of those 3 things. I'm just going to write that plus 1 over here, and you'll know what it means. It's the rest of that. All right, so remember that if you are grading this yourself for whatever reason, maybe we're going faster than we normally do, make sure that you are scoring yourself on the very front side up here. How many points, and add up how many out of 7. You could have gotten 9 out of 7. You could have got extra credit. That is super cool, right? Anyway, moving on to part 2. The rate of raw sewage, doesn't that make you hungry? Enters a treatment tank. There is a function. I'm going to come over here to my y equals and clear, down, clear, up, and retype in our 850 plus 715 cosine, and then, okay, on the top it's going to be second power to get our pi, t squared, and then all that divided by 9. I don't need it in my parentheses, but I'm going to because I'm cool like that. Do I have a negative function? Yes. So if I read my problem, this is the entering. So enters is this positive. I don't want to use red. I want to use blue. Red is reserved for adding points. Enters is this positive word, and removed is a negative word, which means this is the positive function, and my negative function is just negative 645. So in order to do my positive minus my negative, what I'm going to do is I'm going to take my vars right, enter. I'm taking my y1 function, and I'm just going to subtract 645. It's never really worth graphing your positive and your negative rate, either of them. So I should say it's never worth graphing positive or your negative rate. Just graph the subtracted ones. What is our window here? Our window is between 0 to 4. So 0, enter, 4, enter. And I'm going to zoom 0 this thing while we're waiting so I can still talk. Let's actually ask the question. How many gallons of sewage enter the treatment tank during that interval? And notice here, it is restricting us to strictly enter. It's not saying change. If you see the word change, that is the positive minus the negative. If it's enter, it's strictly saying only use the enter equation. Only use the enter equation. So it's saying, hey, take the integral. And I should mention, why are we using the integral? Well, it's looking for number of gallons. Remember that this E of t is the rate. This is kind of like the derivative, or in air quotes, the velocity. If we want gallons and we are given gallons per hour, to get rid of the per hour, you must take the integral. That's why I'm taking the integral. So I'm going to take the integral, and my bounds are already stated for me. It's between 0 and 4 of my E of t function. So I'm going to say of E of t. I don't have to write out the full equation. And I'm going to be formal about this. I'm going to put a dt. I'm only informal when I'm making a table. Even when I'm making a table, I really should be formal. But you never lose points, so I'm not going to do that. That's what it's looking for. Make the calculator do all that heavy lifting, and you've got your answer. So calculator, come on, time to do some work. I am going to do math 9. Where's my math? Math 9, and I'm going to do the bounds between 0 and 4. My vars right, enter 1. I'm doing y1. Remember, y2 is when I subtract them. y1 is just the entering function. I'm only after the entering function. So don't accidentally do y2. And with respect to x, and we get 3,000. So this is going to be equal to 3,981.022. But wait, we're not done, because typically when you do integrals in AP Calculus, the different models of calculators will spit out slightly different decimals. Like it could be off by like 0.5. So they'll usually say answer to the nearest gallon, blah, blah, blah. So that does happen pretty often. So remember to always check for that when you're doing integrals. This is going to turn into, well, that's clearly rounding down because this number is definitely less than 5. It's going to be 3,981 gallons. Excellent. Moving on to part B. All right, for that same window, when are we at the greatest? We're looking for a maximum value. All right, and yep, we're going to round to the nearest gallon. We're going to round again. What is the maximum? Oh, and it's asking for the amount. Okay, hey, I told you in the last problem. Sometimes they ask for time. In this case, they're asking for time. Sometimes they ask for the amount. In this case, they're asking for both time and amount. And you're going to justify the answers with the table, because you always use a table when you have a calculator and it's asking for max or min. All right, let's make our table. We're going to have a T column. We're going to have start plus change is equal to end. And we're going to have some straight lines because we've got technology. Let's show how to use that, Mr. Sindel. Yes, 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 we shall, Mr. Sindel. All right. We need a start. 0. We need an end. 4. We need all relative maximum in our t value. So that's where that graph is going to come in helpful. Again, this is a graph of velocity. We're looking for an amount, which is kind of like air quotes position. So if I'm looking for an amount and I'm given position, what I need to do is I need to take the derivative of amount and find where that derivative goes from a positive to a negative, because that is the definition of a relative max. And hey, this is a graph of the derivative, so really what I'm after is the height change from a positive to a negative. Again, everything is stemming from your speed sheet definitions. The speed sheet definition of an F relative max is, that's supposed to be an X, is F prime changes from a positive to a, ran out of room, negative. Well, F is an amount. This is a graph of F prime, so on this F prime, where do we go from a positive to negative height? And that only happens right here around 2.3-ish. So let's calculate what that value is by doing second trace to do the calculation of the 0 of 2. And it's going to be between 0 and 3, and I'm going to guess, I don't know, 2-ish. And hey, it's right there, 2.309. So I'm going to come back over here, zoom over the right, 2.30, oh, that was a weird lag, 09. Do you need this critical value? Yes, it is a critical value, but it's not a relative max. That is a relative min because it goes from a negative height to a positive height. A relative minimum will never be the relative maximum unless you have a straight line, a constant function, and we do not have that. All right, so I never saw it. Do we have a start amount up here? I totally missed it. Reading. I guess kind of like that. No, that's not really a start amount. I don't see any start amount. So if I don't see anything, my start is 0. So 0, 0, 0, plus, integral. I sound so annoying when I hear my voice out loud. All right, 0 to something. Wait, is it time equals 0? Am I just making that up? Yeah, okay. We started time is equal to 0. Whew, it is good to double check that. Very randomly, like once in every 5 AP tests, they just randomly be like, you know what? I want to start at 1. It's like, it messes all the students up. It should start at 0. Whoa, it just like disappeared. And now it's back. It's magic. All right, and this is going to be these two values must match, etc., etc. 2.309. 4. Excellent. All right. So we need this value to be the positive minus the negative, because that will be the overall change, not just the entering, but the change. So we're really going to do, what letter are we dealing with? We're dealing with E, and then we're minusing the 645. Remember that we already have that plugged into our y2 function over here. We're ready to go. But I'm going to go ahead and, for the sake of the AP graders, show them what I'm doing. I'm going to do capital E minus 645. Same thing over here and over here. Okay, E minus 645. E minus 645. Again, I'm being informal, but that's because I like going fast. All right, calculator. Time to make, I'm thinking of the expression, earn your money, earn your keep. Stop being a leech, right? We paid $150 for you. Let's do something. I'm going to do 0 plus, isn't that so funny? Why'd you do that, Mr. Snell? Just because I'm that quirky. Plus math 9. Between 0 to 0, that would be really silly. 0 to 0, okay, that one we don't care about. 0 to 0 is always going to be 0. 0 to 2.309. Wow, my handwriting almost made me make a mistake. That happens so often with students, I know. That's 2.309 of my vars, right? Enter 2. My y2, that is subtracting them all together. And with respect to x, tell me what you get. Yeah, there it is. All right, so I get 1,637.178 if I round. And let's go ahead and do that as well. Second, oh wait, I meant to do second enter, not second quit. And I'm going to change my bound, and I have too many numbers, so I'm going to hit delete, 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 and 4. Enter. And I get, there it is, that number right there, 1,401.022. All right. Well, kids, we've now done all the heavy lifting. Which one of these is the biggest? And it's going to be that one. And it makes the most sense, especially if we look at that graph, because we have all of this positive area, and these two areas kind of cancel each other out. Well, not really. I would say the negative area outweighs this tiny little positive area. All right, so again, like always, we're going to write out our final answer. And if you just follow my format, you will get both the time and the amount correct, because you have to do both for this problem. So we're going to say max, again, sometimes I write this out in full. Maybe I can say the maximum amount, or I could just be lazy and be like, the max is this. The maximum amount of sewage is, occurs, I'm being super fancy, at T is equal to 2.309 seconds. Well, what are our units here? Do I actually care? It is hours. I see it up here. So I'm going to say 2.309 hours with, and here's something you have to be careful of. Remember, up here it says nearest gallon. We had to round to the nearest whole number. So we can't say the decimal 0.178. It's just the 1,637 gallons. All right, moving on to part C. All right, the cost of treating raw sewage that enters, okay, keyword here. We're only talking about the thing that enters. We are restricting the function to only thing that enters the tank. All right, and this is the cost in dollars per gallon, and then it's asking for the total cost of treating the sewage. All right, so typically in AP calculus, whenever you have a price function, you're just going to multiply that by the inside of the integral, and usually it comes out right. But let's go ahead and see if that makes sense. So my theory here is if we take the integral between 0 and 4, and we take that, we're not doing the overall change. We're not doing E minus 645. We're just doing E, and I'm going to be formal about this because I might lose points. E of t, and I'm going to now multiply this by, and then this is kind of important for the calculator. You need to have parentheses here. Multiply this by 0.15 minus 0.02 t, and then that whole thing dt. So I think this makes sense because if you look at E gave units as gallons per hour. So let me come down here and write down. This was in gallons per hour. And over here, this price equation was given in dollars per gallon. So dollars per gallon is dollars per gallon. And notice that when I multiply these two things, I have this new function. And that function is, well, gallons and gallons cancels out. And this new function is in units of dollars per hour. And of course, when you integrate anything, the time unit just disappears and you're left with overall money, which is the total cost. That does make sense in our context. And just as a reminder, when you take the derivative, you add on one of these times, and when you take the integral, you lose one of those times. It just goes away. So this all does make sense. So let's just enter it in the calculator, and we should get it. So let's come over here. Second quit. We're going to do math 9 to do the integral between 0 and 4. And then this is going to be our, okay, we have to do vars right, enter 1, or enter. That's our entering function, and we need to multiply this with, in parentheses, if you don't have your parentheses, you're doing something wrong, 0.15 minus 0.02x. And I will end the parentheses. Oh, if you hit 2, that's the go-to. 2, I forgot to say, with respect to x, dx. Thank you, Mr. Sindel. Thank you, calculator, for reminding me. And there it is. Yeah, that's the answer we are looking for. This is equal to, I want to go back to blue. This is equal to, it doesn't say round to the nearest. Oh, it does. It does. Oh my gosh, to the nearest whole dollar. All right, so this is exactly, well, I'm still rounding to 3 decimal places. But with those decimal places, it's 474.320, I suppose, 320. But to the nearest whole dollar, this is $474. That's the money that we're looking for. I know some people will try to just take the total amount of gallons that they got from part 1 and just plugging this number in for t, but it doesn't work because that's a time, that's not an amount. You can't just plug that in. And you can't just multiply by this after you take the integral because, again, what is your value of t? Like, you don't know what that value is. So the only thing that would make sense is to do it all in an integral. All right, scoring this thing, zooming out a little bit, changing to our red ink. Again, things should add up to 9, but again, that last question was extra credit. It was a little bit harder. You've never seen it before, but now you have. It's fair game on the real test. So this first question is going to be out of 2. Next question is going to be out of 4. Last question is going to be out of 0, but you could have still gotten 3 points. So that's why it doesn't add up to 9. So 4 plus 2 is 6, 7, 8, 9. Yep, that does work. Okay, so on this first question, you get 1 point if you got the bounds, the integrand, everything. You need to have that d of t. You must be formal about that. And if you did that, you got your plus 1 point. And then finally, if you rounded your answer and got 3,981 gallons, then you get your plus 1 point. Do you lose a point if you forgot gallons? No, it's not specific to say you have to use units in this question. If it says use correct units, then you would lose the point if you forgot your units. For part B, there are 4 points. The first of which, do you consider 2.309? If you had that considered, you get a point. If you found out the total amounts over, I guess if you're, we'll just say this. If you use a table, if you have a good justification of looking at start, relative maximum, and end values, I'll give you plus 1 point for your justification. That's where it says justify, right? And then finally, if you get both of these together, yes, that's the time, yes, that's the amount, yes, it's rounded, all of that stuff, yes, you get your plus 1 point. And finally, what is my last point? Oh, yeah. So for some reason, the guide is telling me, hey, if you found those two, bad curly brace, if you found those two end amounts with the correct decimals, I suppose, more or less, then you get a plus 1 point, which doesn't make a lot of sense to me because I know those decimals are going to be a little bit off. If they're a little bit off, it's fine. If you generally got 2 different end values, that's the point that I'll give you for. All right, again, you could still get some extra credit. These are the extra credit points that you could get. If you have literally the bounds from 0 to 4, you get a point. Hopefully, a lot of people got that. If you got the inside part of the integral, also known as the integrand, which does include the d of t, then you get 1 point. And the last of the 3 points that you can get, if you got $474, rounded to the nearest dollar, that is the last of the extra credit points. All right, skipping down here to number 3, another calculator problem. I've already entered in the equation that we will need. Things to notice about this problem, we don't have any window. We don't know when it ends. We do know that the time is going to start here at time is equal to 0, so that means our integral is always going to be from 0 to something. I also saw an equation, so I put in that equation, and this is an equation that's gallons per day. We're given an equation of a rate. That's good to know. So let's talk about this. The amount of pollutant, is it increasing, or it's not asking decreasing, just increasing. So first of all, we're asked to find an amount, but then we are asked the question, is that amount increasing? Which means we are going to be taking the derivative of the thing we care about. So, and again, that's the keyword increasing or the keyword decreasing or both of them. That always means take the derivative of this thing. The derivative of an amount turns it back into a rate. And we have an equation for that rate. So really what this question is asking for is, hey, this p prime function that is listed up here, what happens when I plug in, whoa, weird lag, what happens when I plug in 9 into that equation? Is that a positive number or is it a negative? If it's a positive, it's increasing. So the quickest way to do that is a second mode equation out of that. I just do vars right, enter, enter, y1, and then of parentheses. So if you don't do the parentheses, this won't work. Of 9. And you get that. Again, the number doesn't matter so much. I'll write it down just for the sake of it. It's negative 0.646. 646. But the main thing is, hey, that number is less than 0. This is a negative number. If it's negative, it's decreasing. So I can come up over here and type in my answer. No, it is not increasing. It is not increasing. I don't know why my program thinks that it has to write in this little box. It is not increasing. And then the why or why not, right? We need a speed sheet definition. Every single time you see a why or why not, it's almost always asking for a speed sheet definition. So why does it do that? Because we can just say p prime of 9 is less than 0. Or you can say is negative if you don't like your less than or greater than symbols. Excellent. Moving forward, part B. For what value of T will the number of gallons of pollutant be at a minimum? Okay, so whenever you have a minimum or maximum question and you have a calculator, you're always going to be making a table. So I'm going to have table with T. I'm going to have a start plus, wow, the lag here is insane. Start plus change. That's going to equal to our end value. And then I'm going to make some straight lines. So I notice the reason why I'm lagging at certain times. Whoa, that line is not straight. Whatever, I think I'm just going to go for it. It doesn't look straight to me. Or it doesn't look like perpendicular to the previous line. But anyway, we need a start time, and our start time we already know is 0 from this beginning of the integral. We don't have an end time. You can't plug in anything down here. So we just have to guess at our window. I don't know. I usually go with 100 is a safe bet. So I'm going to do a window between 0 and 100. And I'm going to zoom 0 this thing. And we're looking, hopefully, for a place where this crosses the t-axis. And okay, it crosses right there. So if that's 100, that's about 50. Let me zoom into 50. So let me go window to 50, and I think that'll be hopefully a little bit clearer. Zoom 0 that thing so we can zoom in here. It's still kind of hard to see, but it's pretty clear. It's crossing around 30-ish, 40, 35, I don't know, somewhere around there. So let's find that value. So second trace to do a calculation of the 0, the 2. I think it's at about 30, so I'm going to say between, I don't know, 25 and 50, and I'm going to guess 30-ish. Oh dang, look how close I was. Yeah, 30.174 if I'm rounding. So this number is going to be, I should write probably smaller, huh? 30.174. All right, our start value, do we have an initial amount of something in here? I don't think there's any initial pollution. So oh wait, it does. Okay, there are 50 gallons of pollutant. I was reading this too fast. When time is equal to 0. So this 50 gallons, that's our start amount. So I'll write this down. Our start amount is right here. Our start is 50. And what is this, 40? 40 is the safe amount. Okay, so once we're at 40. Anyway, you might be able to see up here. When my drive updates, then I get weird lag. And it updates like at minor changes. Maybe I can change the settings of PDF Expert. Food for thought. All right, start 50. Start 50. It'll be really cool if you guys are watching the video like in 2025 or something, a few years down the line. Mr. Sandell, did you ever figure out how to make your computer not lag so much? And I'll probably say no. It's so hard to change all these things. I never have time. The integral is going to be between 0. The integral is always going to start at 0, and then it's going to end at this time over here, 0, and therefore I don't care about it. This one I do care about, and that's probably going to be the answer. That's the only thing that we have, 30.174. And of what thing? It's p prime of t, right? Yeah, p prime of 9. So this is p prime of t dt. I'm being a little bit more formal now. I don't have to be. P prime of t dt. If I had a bunch of table entries, I would probably just say p prime of t. And then we do what that is. And that'll go back to p, but we don't have that function. We just have p prime. So let's second mode out of this thing. Oh, and by the way, I should have mentioned in the previous problem, there is another way to find what the value is at 9. If you go to your graph and you hit trace 9, enter, it'll tell you that exact value. It says, hey, yes, the y-coordinate, or the height of that function, is negative 0.646, which is exactly what we got up here. Anyway, coming back off of that tangent, let's go ahead and do our 50 plus math 9, our integral between 0 and this 30.174 of our vars right, enter, enter, with respect to x, and I hit enter, and I get a number. Well, that is calculated. I'll go ahead and write up here. When I add 0 to 0, that kind of cancels out that, and it's just 50. And then this one is going to be 35.104. And just remind yourself when you're looking at the graph, this is a graph of, like air quotes, velocity of the derivative. So when the derivative goes from a negative to a positive, then the original function, the non-derivative, that's a minimum, a local minimum. And since there are no other values on here, the local minimum is the absolute minimum. It is the answer to this question. So we have the justification with the table. Let's go ahead and write down our final answer down here. We'll say that the minimum, why does it do that? Minimum value is at t is equal to 30.174 with 35.104 gallons. And God, this program is so finicky with text. Just make that a line. Thank you. And it only asked us to find the value of t. It didn't ask to find out what that minimum value was. So we did too much work there, but that's okay. We only need to answer the t. Moving on to part C. Is the lake safe when the number of gallons of pollutant is at the minimum? Okay, so this is kind of like asking for that second half. Remember when I said we just did too much work? Well, now it's asking us to do that. And just as a reminder for the AP test, the AP grader looks at all of these pieces. So that means they see up here, hey, they did all the work of 35.104. I know where that came from. This 35.104 came from them doing start plus change. There's weird lag. Start plus change is equal to end. So this work is explained. You can just basically say, hey, the minimum value, we already found it from our last part. It was that 35.104. And to be safe, if I reread the question up here at the very top, it will be safe if I'm at 40 or less. So 40, if you're exactly at 40, you're safe. But we're definitely less than that. So when we're at 40, that is safe. So our minimum is less than the safe amount. So we are safe. So let me write that out in words. I can type it faster. You can say, yes, the lake is safe at that time equals 30.174. Just reading the problem up above. Why? It's because, well, this number is less than that number. So we can just say 35.104 is less than 40. It's pretty silly to say. My phone is going off because my preschool teacher is sending cute pictures of Riley that I really want to go look at, but I'm going to finish this video first. I want this line to be slightly longer all the way. Please? There we go. And finally, part D. So there's an investigator that's going to use a tangent line approximation as a model for the amount of pollutant in the lake. According to his model, when does it become safe? Okay, well, this guy is a simpleton. He uses straight lines when we calculus students can use cool curves. So his prediction is going to be way off. And look at this. Like if he's using at time equals 0, like look at the slope. At time equals 0, like the slope is going to be crazy. It's going to be like this line that's going to predict, oh, you don't need to wait 35, what are we in, days? You can go in like 3 or 4 days. He's going to be super far off because he's a bonehead. He can't use calculus. Anyway, let's go ahead and do that. Anyway, tangent line approximation. Every single time you see those words, you're thinking of, whoa, weird lag. And it's not updated. I don't know. Okay, so maybe there isn't lag like I thought. Y minus box is equal to box times x minus, oh, I guess it should be t minus box instead of x, huh? T minus box. And what do we know? What can we fill in? Well, the t value that we're looking at is t is equal to 0. What is the initial amount? The initial amount was 50, I think. Yeah, 50 amount for the y. So this is the old t coordinate. That's the old p of 0 coordinate. Oh my God, the pictures are rolling in. I'm sorry, guys. And then what is the slope? So the slope, well, we have an equation that gives us the slope. This is p prime of 0, and we have an equation that gives us p prime, right? That was the original equation all the way up here. If I just plug in 0 into this equation, I'm fine. So it's essentially asking, hey, what is the, there's a way you can do it right here. You can just hit trace 0. And you can get this value. Oh, it's exactly -2. And if you didn't want to do it that way and you were just in here, you'd say var's right, enter, enter of 0. And you get the same value, -2. Okay. So either way, we get a slope of -2. And that's the equation that bonehead is probably going to use. He uses this equation, and he wants to predict when that becomes safe. So he's saying, hey, this value is going to be 40. When does that happen? So let me go ahead and do the math that he would have done, or she. It didn't say it was a male investigator. I am being sexist, aren't I? Sorry. He or she, that bonehead, would use this equation, 40 minus 50 is equal to, whoa, the lag is insane. Come on, let me write equal to. I just want to write is equal to -2t, because t minus 0 is just t, right? Solve that equation. Well, ladies and gentlemen, that's just 10 is equal to -2t. Oh, -10, Mr. Sindel. I was like, why are we getting a negative answer? 40 minus 50 is -10, that's why. Divide both of these by -2, and t is equal to 5. Which, I mean, it might have been safe before 30.174 hours, days, whatever our units were. This was its absolute minimum, but we know that that's around the time that it's the best time. The investigator's like, yeah, jump in the kid, guys, because it's safe, I think. I used a line, so that person's wrong. So I guess we should answer the question, because t equals 5 is not super, I don't know, it doesn't explain itself. So we'll say the model predicts that the lake will be safe after 5 hours. I wonder if there's a setting also that can fix this text from thinking it needs to be collapsed on. Usually what it does is it detects, hey, there's writing here, so it avoids that, but there's no writing to avoid there. All right, well, how do we score this thing? This one's going to be out of 7 points, because this last one is going to be extra credit. I was being very nice to you. So let's start at the bottom, because that's where I am. This one's going to be out of 0 points, so you can get extra credit points. You can get up to 2 points. I will give you 1 point of extra credit if you are able to find the slope. I'm getting weird lag, so I'm trying to make a plus sign. It's just like not, my computer doesn't like me. Maybe I'll do it down here. +1 if you found that the slope was -2, and +1 if you found that at time is equal to 5, the model predicts that you are safe. For part C, I will give you 3 points. 1 point if you agree. And that was a 50-50 shot, right? Yes or no. I'll just give you a point. And then I'll give you a point for the explanation. So I'm looking for 2 things. First, I'm looking for, can you find 35.104? And then second of all, can you say, hey, that number is less than 40? So like altogether, that's +1 point. Part B is also going to be out of 3 points. And how am I going to distribute the points? So I'll give you 1 point if you somehow found this critical value, this relative extremum. I'll give you 1 point if you made a table, so just your giant set of parentheses. That's your justification. And 1 point if you made the conclusion that, yes, that is indeed the minimum amount. And finally, for part A, that's going to be out of 1 point to add up to 7, like I said. And I'm just going to give you 1 point if you said no with the answer, with the explanation. So that's going to be +1 point. You have to have both those. If you miss one of them, again, there's no half credit. You either got it or you didn't. If you forgot to say, because P of 9 is less than, P prime of 9 is less than 0, then you don't get your point. Excellent. Well, let's move on to the multiple choice questions. Oh boy. Yeah, so this is a review question. We're only talking about continuous. If it was differentiable, then I would have to also take the derivative of both of these pieces and set them equal to, but it's only continuous, so I just have to set them equal to each other with no derivative. So first I set the left, and I can zoom in here. I don't know why I'm zoomed so far out. You can see how pixelated my problem is. You set x squared plus b of x is equal to x, and then you plug in your suspect point 5 for x. So now this is going to be 5 squared plus b times 5 is equal to 5. All right, that's going to be 25 minus a 5 is going to be 20. Oh, maybe I should move it to the other side, right? Because b is on this side. So 5 minus 20 is negative 20, is equal to my 5b. Divide both sides by 5. b is equal to negative 4. Correct answer here is C. Oh boy, the lag is real. All right, part number 5. Where is this thing decreasing? So just as a reminder, decreasing means I take the derivative of whatever I'm talking about. In this case, I'm talking about f. So take f prime, and that needs to go from that needs to be a height of a negative. So f prime is negative. So that happens wherever f prime is equal to 0. That has a potential of switching between a positive and a negative. So I'm going to take the derivative, set this thing equal to 0, and find where the height is negative. First things first. The derivative. I guess I don't need the calculator anymore, huh? Go away, calculator. You were nice while you lasted. Let's not show the homework from behind my project. F prime of x is equal to 5 goes away. 15x turns into 15. 6x squared turns into a 12x. And x, or this minus x cubed, turns into a minus 3x squared. All right, we've taken the derivative. Let's set this thing equal to 0. So now I have 0 is equal to 15. Actually, instead of just rewriting that, I'm going to go ahead and start factoring this thing. The first thing that I see is that my x squared term it has a negative coefficient, which is really bad for factoring. You generally want this to be a positive. So let me factor out a negative, and let me factor out the greatest common factor. 15, 12, and 3. Oh, okay, 3. 3 is the greatest common factor. And when I factor that out, I'm left with a positive x squared. I'm left with a negative 4x, and I'm left with a negative 5. Excellent. Let's go ahead and keep factoring this thing. This 3 doesn't go anywhere. I'm still going to be leaving it there just to remind myself to not forget it in the future. This is going to be x minus 5 and x plus 1. If you forgot how to factor, what two numbers multiply to negative 5 and add to negative 4? Answer, negative 5 and 1. Cool. We have this thing all the way factored, and you'll really quickly see, hey, we have our critical values at positive 5 and our negative 1. So those are our critical values, and they also happen to be relative extremum because these are both to the power of 1, which is an odd number. Odd numbers are always relative extremums. That means that they're going to switch between a positive and a negative. So let me go ahead and mark where those relative extremums are. We have negative 1 and we have 5. I need to test one value, and I typically like plugging in 0. It's the easiest one. It's in between negative 1 and 5. I guess if it was to scale, I would be drawing it right there, but I'm lazy. I'm going to put it in between. If I plug in 0 into the original function, which is why I did not divide by negative 3. Yes, you could have said, yeah, divide both sides by negative 3, divide by negative 3, and then 0 is equal to all of this. It's kind of like ignoring the negative 3 altogether, but I left it there because that's a negative. Well, I guess I should be writing it down here. That's a negative. This is going to be a negative when I plug in 0. 0 minus 5 is negative 5, which is a negative, and 0 plus 1 is 1, which is a positive. These three things multiplied together gives us a positive. And as I told you before, it's going to switch from a positive to a negative when it jumps over these relative extremum because this is an odd power. So it's a negative and a negative. And again, I'm trying to find where this, I was supposed to circle this, where this f prime, this function down here, where is this negative? And it happens to be negative bigger than 5 and less than negative 1. Bigger than 5 is right here. Less than negative 1 is right here. The correct answer is D, as in delta. Use that native phonetic alphabet, right, Mr. Snow? Number 6, we have a function. Oh, it told us the derivative, and it tells us our starting value. Okay, we're looking for an approximation. Approximation using the line tangent to the graph. That is another keyword saying, hey, we have this, whoa, that was weird, y minus box is equal to box times x minus box, this tangent line approximation. And what is our initial x and y coordinate? Well, our x is 0, our y is 1. So 0 and 1. How are we going to find our slope, our f prime? Well, they gave us an equation for f prime. I just have to plug in my x coordinate into this x right here, and I'm ready to go. 3 times 0 is 0. 0 minus 2 is minus 2. So negative 2 is our slope. I have my tangent line equation. And from there, I'm going to approximate 0.01. So here I go. I'm going to use this equation that I built, and I would like to not have lag. Y minus 1 is equal to negative 2 times, and now my x now is going to be changed to 0.1 to see what height I get. So now this is going to be 0.1 minus 0, but I'm just going to write that because minus 0 is the same thing as just 0.1. All right, time to do some really quick mental math. 0.1 times negative 2 is negative 0.2 is equal to this y minus 1. Go ahead and add 1 to both sides. Y is equal, whoa, weird lag still. Why is it not like the y? Y is equal to 0.8. And boom, that's C. Moving on to number 7. We got 2 more left, right? Again, all these are no calculators. I'm taking the integral. Ooh, and there's no anti-product rule. I must have to pay tax, man. You know, that's what's going on here. Okay, so who is my u? U, well, I'm going to take the harder thing. That has more terms. That has fewer terms. So I'm going to take more terms. That's e house. The u of e house is the exponent, x to the power 4. So u must be x to the power 4. My tax person is going to be x to the power of 3, knocking on the front door, x to the power of 3. And when I take u prime, I get, okay, take the derivative. 4 comes down in front, 4x. 4 goes down to the power of 3. There it is. All right, so now let's figure out, what do we pay tax person? X to the power of 3 and x to the power of 3 cancel each other out. This is going to be 1/4, which is excellent. You don't want to have a variable in here. I don't have to pay tax on a variable rate. My new problem is the integral between 0 and 1 of 1/4. Again, this x to the power of 3 is changed into 1/4. And then I still have that e to the power of x to the power of 4 dx. Now that I've paid tax person, I have permission to take the antiderivative. And luckily for us, the antiderivative of e house and the derivative of e house is just e house. So this is going to, I just rewrite it, 1/4 e to the x to the 4th. Now evaluation bar between 0 and 1. Be careful, typically with e house, you still have to plug in 0. If it was powerhouse, usually you can forget it. Just don't forget it. So when I plug in 1, I have 1/4 e to the power of 1 to the power of 4. And then I'm going to subtract when I plug in 0. That's going to be 1/4 e to the power of 0 to the power of 4. All right, simplifying each of these. 1 to the power of 4 is 1. E to the power of 1 is e. So this is just 1/4 of e. That was a bad e. That's a better e. Minus, okay, 0 to the power of 4 is 0. E to the power of 0, anything to the power of 0, is 1. 1 times 1/4 is 1/4. And it looks like this answer is just factoring that out. Again, this is the same thing as 1/4 times e minus 1. And that is A. Excellent. Moving on to our final question for the pretest. Here we go. I know, it's a long video. We have an equation of velocity, and it tells us our starting position. And our starting position happens at time is equal to 1. Ooh, that is a tricky question. Usually time always starts at 0, so be wary of that. What is the position? Okay, so it's looking for an end position. We're going to do our start plus change is equal to end. We're looking for end position. Well, our start, I just said, was 7. Our change is going to be integral not between 0, but between 1 and the time that we're after. Excuse me. Our time that we're after is 2. So 2, I guess I can have like a little T table and say, yeah, we're looking for 2. And that table looks a little bit better. And we're going to just say velocity. Oh, but we don't have a calculator, so we have to actually manually do this. Okay, I'm going to write in here 4 minus 6t squared. And once I do that math, don't forget about the 7. Here we go. Then I'll be done. So antiderivative, there's no house here. I mean, house of powerhouse, but there's the inner here is t, which means dinner is 1. You don't have to pay tax person in this case. So antiderivative is going to be, 4t minus antiderivative. T goes up to the power of 3. This can be a 6t to the power of 3. Divide down by that 3 in the evaluation bar between 1 and 2. I'm going to bring down the 7. Otherwise, I think I might forget about him or her. I don't know. Is it a female or male? 7. Here we go. That cancels out to just, maybe I should do that in a different color. That cancels out to 2. And plug it in here. I get 7 plus, okay, plug it in 2. It's going to be 8. Whoa, weird lag. 8 minus 2 times 2 to the power of 3 is 8. And then that was when I plugged in 2, and then I have to subtract what happens when I plug in 1. When I plug in 1, 4 times 1 is 4 minus, if I plug in 1, 1 cubed is 1. 1 times 2 is 2. I can say 2 times 1 if you want me to show more of my work. And I just need to simplify this thing. Okay, 8 minus 2 copies of the 8 is a negative 8. And then 4 minus 2 is 2, but I'm going to make that. So this right here is 2, and then negative 2, right? Minus that 2. And then I have a 7 that I have not forgot about. Negative 8 minus 2 is negative 10. Negative 10 plus 7 is a negative 3. So the end value here, I did include the 7. I have not forgot about it. I will double check that. Is a negative 3. And yay, I was worried. That is one of the answers. All right, so just as a shortcut way of saying what all the multiple choice letters were, if you want to just look at the end here, it was C, D, C, A, and that last one was C again. Okay, so if you're at this point in the video and for some reason you're grading your own pretest, please go through, add up your total number of points for problem 1, 2, and 3, and each multiple choice question. Each multiple choice question is worth 1 point. So the total does add up to 25 here. That makes sense because 7 plus 7 is 14, plus 6 is 20, plus these 5 multiple choice questions. You can get extra credit here, which is pretty nice. And I will do the conversion on how that converts to an AP score based on past data. I'm using John Wynn's past data. That is it, guys. Thank you for watching, and I will see you guys later. Good luck studying.